Hey guys, it's Mr. Murray. Today we're going to be talking about solving Hardy Weinberg problems and how to see if in other words, how to see if a population is in Hardy Weinberg equilibrium or not. And so what we're doing with this is we're effectively looking to find out how frequent certain alleles are. And as I was thinking about this morning, there were some turkeys outside, and so we're going to use a population of turkeys as our example. And so we're going to say in turkeys, so we're going to do an example problem here. We'll go over how to do it as we talk through this example problem. So we'll say in turkeys, we'll have a trait for, I don't know, what do we have a trait for? We'll just say 4 toes. And we'll say, no, there's a T, sorry. We'll say that trait is found in 25% of the population. Okay, we're going to say that's a recessive trait. And I'm actually not talking about the trait when I say that. What I'm saying is that 25% of the turkey population in Pembroke, Massachusetts is going to be recessive for that trait. Okay, so I'm not really talking about the trait. I'm saying how many turkeys are recessive. Or they have the recessive phenotype. Okay. All right. So that's sort of the beginning of this. Okay. So that's where I got to start with. Okay. So when this whole, how do we figure out allele frequencies? Conversation was going. We need to separate the actual trait from the alleles. So, for instance, what we're talking about? We're talking about 4 toes, right? So, whoops, sorry guys, changed color. If we're talking about 4 toes, here we go. The individuals that have the 4-toe trait, which we'll say is recessive, would have to be, let's say, little t, okay? So that's them. But what I want to know is not so much them, because I already know that, but I want to know what's the frequency of just this allele, okay? So what I have to do is I have to solve this with the Hardy Weinberg equilibrium equations. And so they start like this: P plus Q equals 1. They start with this assumption that the frequency of the dominant allele and the frequency of the recessive allele will those equal 1? And in this case, 1 equals 100%. Okay, that's the whole. So in other words, they're saying there's only 2 ways to have this trait for these problems. The problems can get more complex from here, but there's only 2 ways to have this particular trait. You can be dominant or you can be recessive. Okay, moving on. So that's the first part of the equation. Then they said, well, that doesn't really help us because individuals out there aren't just dominant or recessive. They can be heterozygous. We know they can be homozygous dominant or homozygous recessive. So what they did was they squared that equation. And when they squared this side, it was no big deal. That's just a 1. But when they squared this side, they had to do a whole binomial thing. And it gave them sort of a different equation. It gave them p squared plus 2pq plus q squared equals 1. All right, so when this happens, when we've squared this equation can allow us to talk about phenotypes. I'm sorry. can allow us to talk about genotypes of individuals. Okay. Whereas before, this equation was really just talking about alleles. Okay, so most of us have two alleles for all our, folks have two alleles for their traits in most cases. And so that's why we need to use this equation here. Okay, so all right, let's dig in. How do we solve a problem? Let's go back to our turkeys here. We said they were 25% of them were recessive. And so the recessive individuals are going to have two of those Q's. So they're going to be Q squared. So that's going to be the frequency we see. Or how often do we see recessive individuals? All right. Put a star here for yourself on your paper, because these are where we start our equation. Okay. These are the big guys, because they're the only ones when I look at a population that stick out. Let's go back to our turkeys for a minute. When I look at my turkeys and I see 25% of them that are recessive, let's say I have 200 turkeys and 50 of them are recessive for this four-toed thing. Well, that's how I can count what's going on with the alleles in the population, because there's two other ways to be a turkey with this trait. Of course, this trait's made up, y'all know, I hope. There's two other ways. The other way is to be heterozygous. One other way is to be heterozygous. So these individuals are heterozygous for the trait. And another way to be a turkey is to be homozygous. Uh-oh. I lost my pen here. I don't know why I lost my pen, guys. Oh. Okay. All right, we're going to come back to this. I think the pencil ran out of batteries. So we're going to come right back to where we are right here in our next video.